Okay, today we're going to talk about the software that comes with the Raspberry Shake 4D. It's the software that you load into the SD card that's placed inside of your Raspberry Pi computer. And so what I want to demonstrate now is just that everything is working and that the data is flowing to the server nicely. And so we're measuring here with the oscilloscope. You'll see in the background here, this is the data that we're measuring directly off the hardware. And so if I just lightly tap on the table like I'm doing now, you'll see some waveforms come up in the background there. Okay? So that data is passed down into the Raspberry Pi computer through a serial connection. Here's the header that plugs into the Raspberry Pi computer. And then when data sharing is enabled, that data goes up into the cloud server and then is available for viewing in a number of different programs. And so I'm just going to zoom back a little bit here. I have the data here. It's coming down from the server. I'm going to tap on the table, and you'll see it over here. And you see the waveform coming in here too. So all that server connectivity has been solved and is working nicely. If you open up Swarm here, this is a program that is available from the United States Geological Survey. And it's a program that allows you to go in and look at any of the data from any Raspberry Shake in the world. So if anyone has data sharing turned on, you can access their data here and take a good look at it. And so that's fun for people who live, say, in England where there's not that much seismicity. They can queue into a Raspberry Shake from New Zealand, for example, and look at a station that's detecting and recording, let's say, dozens of earthquakes per day. And so I have up here just 4 different screens, one's for each component in the Raspberry Shake. So we have the acceleration channels here, and then this is the weak motion velocity channel. So I'm just going to go ahead and expand that. And we're looking at an earthquake here. And this is a little earthquake that was detected here in Panama today. And then you can see the spectrogram of that. And so when you get your Raspberry Shake 4D, you'll be able to sign into the Raspberry Shake's web interface. And this web interface is just hosted right inside of the Raspberry Pi. And so this will tell you up here the channels that you have available. This is the network is the amateur network, and the station name is RA265. This is the location code, and then these are the channel codes. So E is telling us that we're now operating at 100 samples per second, and then HZ, NZ, NN, and NE, those are the channel codes. So we have a 4-channel unit. So to get your data to go up into the cloud, what you'll do is you'll just go into the settings area here, you'll choose forward data on, you'll answer some real short questions, choose your geolocation, and then hit save and restart. And then your data will automatically start appearing inside this station map. And so here is the Raspberry Shake network from the original Kickstarter campaign. Right now there's 325 or so stations. And so as soon as your triangle appears, you'll just go ahead and click on it. Let's say this one. And you'll get a data stream here of the last 10 or so minutes of real-time data. And there's a new web interface that we're developing that's going to be in addition to this configuration page. And it's going to look something like this, where we have a spectrogram. There's a waterfall of a spectrogram that's done on the continuous data. The real-time data is going to come in along the bottom here. And then we're going to have some system parameters up here, as well as the heliquarter tool. And just one more thing to show you before we close out this video is I was playing around in recent months with the Raspberry Shake 4D, and especially the acceleration channels, because I wanted to see how well it compared to some of the more professional grade equipment that we have in the lab. And so back over here down on the floor, we have a bunch of equipment and testing, and co-located with that right down in there, those green sensors, those are really, really professional grade seismometers and accelerometers made by the Nanometrics company in Canada. And so those bad boys cost a few $1,000s a piece. Actually, many thousands of dollars a piece, not just a few. And so what we have up here, this is one of those professional grade accelerometers. And then we have below that, we have 2 Raspberry Shake 4Ds. And what I'd like you to see is that the waveforms on these are nearly identical, okay? There's a polarity reversal on the Raspberry Shake 4Ds, but that's been fixed in the firmware, so now they have the real polarity that they should have. But at least they recorded the event beautifully here. And this is a magnitude 5.5 event that occurred very close to where we are here in Panama. And so I'm going to go to one more graphic that just shows you the same thing. The top is the professional grade accelerometer, and then below that are 2 Raspberry Shake 4Ds. And this is the Spectra. And so what we're looking at here along the bottom axis is the frequency from 0 to 50 hertz, okay? And so most of the earthquake energy is up in here around 10 hertz, okay, down to about 1 hertz. And it matches just beautifully with the professional grade seismograph. So that's it for today. See, we still got the continuous data coming in. Click on the table here. So all of that hardware and integration with the Raspberry Shake server is truly functional. Okay. Thanks for supporting us, and I look forward to your questions during the campaign.